Flipped classroom video for Maths A2 Unit 3, Modulus Inequalities. So, modulus inequalities, let's have a look at a basic inequality. We want the mod of 3x minus 2 to be less than 7. And what that tells us is that 3x minus 2 itself must lie between 7 and minus 7. Sort of obviously it must be less than 7, but the reason it must be greater than minus 7 is if we take a number that's less than minus 7, so say minus 8, when we modulus that, that becomes 8, which is then not less than 7. Okay, so it's a general rule that if mod x is less than a, then x lies between minus a and plus a. Okay, now for this equation we can add 2 to each part of it. That's just lifting the whole thing up by 2. So all the relationships stay the same. So we have minus 5 is less than 3x is less than 9. We can also divide by plus 3. If we were divided by a negative, of course, we'd have to reverse all the inequality signs, but dividing by 3 gives us minus 5 over 3 is less than x, which is less than 3. So x lies between minus 5 over 3 and 3. We can do a graph of that. The line 3x minus 2 starts with a dotted line and then draws up. We reflect the dotted bit in the x-axis, and then we can see where the line y equals 7 is, and we can see that it crosses at minus 5 over 3 and at 3, and so therefore only the parts of the sort of v that's below that y equals 7 line are satisfactory for us, and there we have it. So that's the bit we want. Now we can also, in basically the same sort of way, we can solve mod 3x minus 2 is greater than 7, because then we either have 3x minus 2 is greater than 7 or 3x minus 2 is less than minus 7. And in general, if mod x is greater than a, then x is less than minus a, or that union sign means or x is greater than a. So those are the possibilities. So you've got to be very careful always with moduli. A bit like with squared things, it splits into two cases some of the time. In this case, we've got 3x minus 2 is greater than 7. That means 3x is greater than 9, which means x is greater than 3. And of course, these are going to come out with the same numbers as we did before. And that's now shown with that little green sort of line on the graph there. Oh, and showing that it's the numbers greater than 3 that satisfy it. And then we solve the other one. We get the same thing coming out. X is this time less than minus 5 over 3 rather than greater than. And that shows the portion of the graph and then the values of x that satisfy that condition. As before, with the equations, we have the alternative of squaring. So this time, if we square this, we have 3x minus 2 squared is less than 49 for the original inequality. That means 9x squared minus 12x plus 4 is less than 49, which means 9x squared minus 12x minus 45 is less than 0. We can divide through to get 3x squared minus 4x minus 15 is less than 0. And that gives us 3x plus 5 brackets times x minus 3 bracketed is less than 0. And whether you've got less than or equal to, greater than or equal to, at this point you need to consider 3x plus 5 times x minus 3 equals 0, because that will allow you to do this little sketch. So if that equation were equal to 0, then we can see that the x values would be minus 5 over 3 and 3. We know it's a positive quadratic. We've got a positive 3x squared there. So that means it's a cup rather than a cap, or a U shape rather than an N shape. And so the graph looks like that. And from there, for the less than 0, we just have to look below the line, and that tells us that we have the values between minus 5 over 3 and 3. And if we were to want the other part, so the green writing from above, mod 3x minus 2 being greater than 7, then we would need the parts above the line. So that sketching of that little quadratic is essential to me if you're solving it using the squaring method. Modulus both sides. Okay. Find the values of x which satisfy this inequality. Now this is getting a bit nasty. We've got moduluses both sides, so that means there's going to be reflections going on for both graphs and all sorts of things might happen. So let's go through it step by step. First step, find values of x for equality. So we're going to find where these graphs do cross. And we've seen this in the previous video, and we saw that there are two cases. We've either got 2x minus 5 equals positive 3x plus 1, and that gives us x is minus 8, and we have negative 2x minus 5 equals 3x plus 1, and that gave us x equals 2/5. The next thing to do, and this is a wise thing to do, is to draw a sketch. Not everybody would, but my advice is draw a sketch. And again, we have this sketch from the previous video, so it's copied there. That's in red, we've got our mod 2x minus 5, and in purple we have our 3 mod x plus 1. Now, from the picture from the last video, we will actually extend those lines so we can see where they cross, and this is not very well to scale because I think they crossed at minus 8. Yes, they did. So, but we don't. It's not too bad to scale. Not too bad. I've done worse for sure. Anyway, the point is that we can now see which values of x will satisfy our inequality, because we need the 2x minus 5, the red graph, to be above the purple graph. And we're just putting in the 2/5 as a 0.4 there, and that works okay. So where is the red graph above the purple graph? Well, to the right of 0.4, because the purple graph is a steeper gradient, it's always going to stay above the red graph, so that's no good to us. Between 0.4 and minus 8, then the red graph is above the purple graph, but then beyond minus 8, the purple graph is above the red graph. So we can see from the graph that this inequality is satisfied when x lies between minus 8 and 0.4. We'll also have a look at the modulus of x within an inequality. So for example, we might have 3 times the mod of x plus 1 is less than 2 take away the mod of x. First step, find values of x which give us equality. And we've seen this in the previous video, and we saw that there are two solutions, x equals plus or minus a quarter. Now we want to draw a sketch, and again we saw this in the previous video, and we've got the graphs labelled there, so we can see that the brown one, which is the 3 mod x plus 1, is less than 2 minus mod x for values of x between our two solutions, and that means we have the lower boundary of minus 0.25 and the upper one of 0.25. So x lies between minus a quarter and a quarter, or x is greater than minus 0.25 and less than 0.25.